In this video, we'll be looking at Chapter 11, Section G, on sampling with and without replacement. Sampling is simply taking an object from a larger group and inspecting it for some particular feature. Sometimes we want to put the object back after we have found out what we're looking for. For example, if we remove a marble from a bag of marbles to check its color, we can then put that marble back in and resample for another marble. So a sample with replacement is where an object is put back. Sometimes it's impossible to put the object back. For instance, if we want to check to see if an egg has a double yolk, we need to break the egg to inspect it, and it's impossible to put the egg back together again. So without replacement, the object is set aside. In both cases, we can use a tree diagram to calculate the probability of a specific event occurring, but we need to be careful when calculating the probabilities for the second column, whether or not the object has been replaced. So when you're solving problems of this nature, be sure to look for keywords such as the object is replaced, or the object is set aside, to figure out whether or not you're using replacement or not replacement to figure out the probability. Let's take a look at an example problem. In this case, we have a bin that contains 4 blue and 5 green marbles. A marble is selected from this bin and its color is noted. It is then replaced. A second marble is drawn and its color is noted. We want to determine the probability that both marbles are blue, the first is blue and the second is green, or that there is one of each color. We can draw a tree diagram to represent this experiment, and our first column will be marble 1, and our second column will be marble 2. Now our options for the first marble are blue and green. And the probability of drawing a blue marble is 4 out of 9. And the probability of drawing a green marble is 5 out of 9. Now the second marble can either be blue or green in both cases. Remember, because we're putting the marble back, because we're replacing it, the probabilities for each individual marble are not going to change. Again, we're going to have 4/9 for the blue marble and 5/9 for the green. And we can write these probabilities right on the tree branches of our diagram. Now for part A, we're trying to find the probability that both marbles are blue. So I want to follow the branch that gets me 2 blue marbles. And to find that probability, I want to multiply along that branch. So I want to multiply 4/9 by 4/9. And that's going to get me 16 over 81. That's my probability. For part B, we want to follow the branch where the first marble is blue and the second is green. Likewise, I want to multiply the probabilities along those branches, so I'm going to have 4/9 times 5/9, and that should get me 20 over 81. Now the last question wants me to find the probability that there is one of each color. Well, I've already found the probability of one of those cases, blue and green. Now I want to find the probability of drawing a green first and then a blue. And again, I want to multiply along the branches. So 5/9 times 4/9, again, it's 20 over 81, but I want to add these two because both get me the outcome that is desired. So really I have 40 over 81. Let's take a look at another example. In this case, we have Silk, and she has bad luck with the weather when she takes her summer holidays. She estimates that it rains 60% of the time and it is cold 70% of the time. And we want to draw a tree diagram to illustrate this situation. Our first column can be temperature, and our second column can be rain. Now for the first column, it could either be cold or it could be not cold. And in the second case, we could have rain or we could have no rain in both cases. Again, we want to fill in the probabilities along the branches of the tree diagram. So in the first case, it's going to be, we have a 70% chance that it's going to be cold, which means that Silk has a 30% chance of it being warm on her holiday. And there's a 60% chance that it's going to rain, which means there's a 40% chance that it won't rain. And these are the same probabilities here. We're then asked to find the probability that for Silk's holiday it is going to be cold and raining. And again, we want to follow the branch where it's cold and raining and multiply the probabilities. So I have 0.70 times 0.6, which is going to get me 0.42. So that's the probability that her holiday will be both cold and raining. And then we want to find out if it's going to be fine or good temperature, no rain, and cold. So in this case, we want to follow the branch where it's cold and not raining. And so we want to multiply 0.7 by 0.4, and in this case we get 0.28. So again, just to highlight the paths here, and sometimes it's useful to use arrows. We have cold and rainy for the first question, and we have cold and not rainy for the second question.